The problem is that we got the latest image and it looks like a single object in the middle. So we don't know what is going on. Of course, it's possible also that these are thrusters from a technological object that are used to maneuver or navigate. And obviously, in that case, they will maintain their orientation. So the verdict is still out. And I'm very much looking forward to getting more data in the coming weeks. You know, that's the way science should be done. It's like a detective story. And any of my colleagues who claims to know that it's a comet of a type that is familiar to us, you know, is not really curious or imaginative.
The 12th anomaly has arrived, and it has shaken the scientific community to its core. Astronomers, observing the interstellar comet 3I Atlas, have detected something that, by all known physics, should not be possible. The orientation of its jets remains fixed, unsmeared by the object's rotation. This revelation, published by astrophysicist Avi Loeb, suggests that 3I Atlas, already famous for a string of puzzling behaviors, may be defying the basic mechanics that govern every natural body in motion. The finding doesn't merely challenge expectations, it tears at the foundation of how we understand outgassing, rotation, and the subtle choreography of cometary physics. 3I Atlas rotates roughly every 16 hours. If the jets were being produced by sublimating ice, their direction should vary dramatically over that period, each plume tracing a circular smear across the void. Instead, they remain narrowly aligned, as though locked to a single orientation in space. These are not faint wisps. They extend more than 1 million kilometers from the comet's surface, moving at hundreds of meters per second. The precision with which they maintain their aim has left scientists stunned, unable to reconcile the data with any conventional model of a rotating, venting body. This discovery marks the 12th major anomaly associated with 3I Atlas since its detection, a running tally that has turned the object into one of the most enigmatic visitors ever recorded. From its unexpected brightness and acceleration patterns to its strangely stable fragmentation, each observation has raised new questions rather than resolving old ones. But this latest finding eclipses the rest in significance. If confirmed, it could indicate a physical mechanism unknown in natural comets, or, as some have cautiously speculated, behavior that might resemble controlled propulsion. In observatories and research forums worldwide, disbelief has given way to calculation. Astronomers are reanalyzing telescope data, rechecking rotational models, and replaying the numbers with mounting unease. 3I Atlas, once just another fleeting traveler between the stars, has now forced the scientific world to confront the unthinkable, that something crossing through our solar system may be operating under principles we do not yet understand. The story of 3I Atlas has unfolded like a serial mystery, each chapter revealing a new irregularity that refused to fit within the known boundaries of comet behavior. Its first anomaly came with its light curve, a brightness pattern that changed too rapidly to be explained by simple sublimation. Then came an unexpected acceleration that could not be accounted for by the standard pressure of solar radiation. Observers noted an absence of the expected dust tail, a puzzling lack of debris for an object supposedly venting material into space. When its trajectory shifted slightly, the deviation pointed to an uneven force acting upon it, yet the mechanism remained invisible. As the list grew, 3I Atlas began to resemble less a passive fragment of ice and more an active agent of physics. By the time the 11th anomaly was logged, a curious sequence of fragmentation events that produced subcomponents with coherent motion, the object had earned its reputation as the heir to Oumuamua's enigma. Each irregularity seemed to mock human models of cometary evolution. Still, researchers kept looking for natural explanations, exotic ice compositions, layered crusts, and unknown phase transitions. Then, in late 2025, came the 12th anomaly, and with it, a sense that perhaps nature was not enough. What astronomers observed this time was unlike anything previously recorded. The jets emerging from 3I Atlas appeared to fire in straight, unwavering lines, maintaining perfect alignment for hours and even days. Normally, when a comet rotates, such emissions twist around the nucleus, forming spiraling or fan-shaped patterns as jets trace the object's spin across space. But the jets of 3I Atlas stood still, sharp and directional, like laser beams beams etched into the darkness of interstellar space. They did not flicker or bend as the nucleus turned. They maintained their aim with uncanny precision. This was not a trick of a single image or momentary flare. Successive observations from multiple telescopes confirmed the same rigid geometry. Even after several rotations, the orientation of the jets remained fixed, as though the object itself were locked on a cosmic target invisible to us. The steadiness persisted despite careful calculations showing that the comet completes one full rotation every 16.16 hours, a rate that should, by all logic, produce visible smearing in the emission pattern. Every point on the surface should eventually face away from the sun, venting in new directions as different regions heat and cool. Instead, the jets acted as if they were anchored to an external coordinate system, obeying no rotational rhythm. The effect is so extreme that some researchers compared it to a spinning garden hose that somehow keeps its stream perfectly straight no matter how the nozzle turns. The contrast between motion and alignment borders on paradoxical. The object was rotating, yet the plumes were not responding to it. The numbers make the contradiction even sharper. A rotation period of roughly 16 hours means that any fixed vent on the surface would sweep through a full 360 degrees during that span, effectively painting a broad cone of gas and dust into space. Given that the jets extend more than 1,000,000 kilometers, roughly 3 times the distance between Earth and the Moon, and eject material at velocities near 400 meters per second, even a minor rotational offset should introduce measurable curvature. Over time, the trails should blur into a diffuse halo. Instead, telescope imagery shows streams that remain astonishingly collimated, retaining the same crisp lines across multiple observation sessions. That degree of precision implies an almost active regulation, as though the venting mechanism is adjusting in real time to counteract the spin of the body.
For such compensation to occur naturally would require forces or geometries never before identified in a comet. One possibility would be if the jets were not surface-based at all, but emerged from deep subsurface conduits that somehow rotated counter to the outer crust, an arrangement more reminiscent of engineered machinery than geological process. Alternatively, the emissions could originate from a structure or composition capable of maintaining an inertial reference frame independent of the object's spin, though no known material or physical process fits that description. In plain terms, for the jets to remain this stable, 3I Atlas would have to be stabilizing its own thrust, actively resisting its rotation to keep its emissions fixed in space. That idea, while thrilling, sits at the very edge of scientific imagination, hovering between the improbable and the impossible. Such precision hints at a level of internal order far beyond random venting. Even if the explanation proves natural, the mechanism must be profoundly unique, perhaps involving the interplay of magnetic fields, pressure differentials, or exotic ice structures unseen in our solar system. Yet to many who study celestial dynamics, the phenomenon carries an unsettling undertone. Nature, elegant as it is, rarely crafts such geometric perfection. 3I Atlas, in this moment, has become a mirror for human curiosity itself, forcing us to decide whether to stretch our models to fit the data or to admit that we might be glimpsing something entirely new in the dark. Naturally, the first task of every serious researcher was to search for ordinary explanations. Could the apparent steadiness be an illusion created by viewing geometry? Perhaps the axis of rotation was aligned with the direction of the jets, producing a deceptive sense of stability. Or maybe hidden pockets of ice were erupting from a region that, due to the object's orientation, stayed consistently sunlit. Another possibility suggested complex surface topography, deep depressions or cliffs that could channel outgassing into narrow streams, preserving alignment. Yet each scenario collapses under scrutiny. A rotation-aligned jet would still show subtle oscillations, continuous solar illumination would shift as the object moved. Topography alone cannot explain kilometer-long coherence over days. The data persistently resists the ordinary. And so, inevitably, speculation has drifted toward the extraordinary. Some scientists have raised the uncomfortable question, could 3I Atlas be demonstrating an artificial form of control? The idea evokes the earlier debates over Oumuamua, which Loeb famously argued might represent alien technology. Critics recoil at the comparison, pointing out that extraordinary claims require extraordinary evidence. But the behavior of 3I Atlas now straddles a similar boundary. Jets that maintain stable orientation despite rotation resemble, at least superficially, the operation of directed propulsion or thrusters. Such a notion challenges not only astrophysics, but philosophy, forcing us to ask whether we would even recognize the fingerprints of non-biological intelligence if they were written in cosmic mechanics instead of radio signals.
Even if the phenomenon proves natural, its implications are seismic. A new category of cometary activity may need to be defined. Objects whose jets are guided by internal structural dynamics we do not yet understand. It might suggest layered materials that redirect sublimation, or compositional gradients capable of self-stabilizing vent flows. Whatever the answer, it demands a re-evaluation of how outgassing forces interact with rotation. Traditional models assume random venting from sunlit regions, leading to predictable torque and spin. 3I Atlas shows a level of order that contradicts those fundamentals, hinting that interstellar objects could carry entirely new architectures of ice and mineral. To quantify such mysteries, Loeb introduced a scale of anomalies, a conceptual ladder that measures how far an observation deviates from established physics. Each rung represents a growing departure from natural explanation, from the merely unusual to the deeply puzzling to the realm that borders on the technological. On this Loeb scale, 3I Atlas already ranks near the upper end. Its previous 11 anomalies placed it among the most statistically significant outliers in interstellar observation, but the 12th may push it even further toward what Loeb cautiously calls the frontier of technological significance. That phrase does not claim alien origin. It simply defines the point where conventional physics runs out of vocabulary, and something unprecedented must be considered. Yet, Loeb himself remains notably restrained, emphasizing that science advances not through speculation, but through repeatable evidence. Extraordinary evidence, he reminds, means reproducibility and transparency. His argument is not to sensationalize anomalies, but to keep inquiry open until the data themselves close the case. To him, the danger lies not in over-imagining possibilities, but in prematurely dismissing them.
The next stage in the investigation is already underway. High-resolution monitoring from both ground-based observatories and space telescopes aims to capture the jet's evolution over multiple rotations. Spectroscopic analysis will seek chemical signatures that could distinguish natural ice vapor from dust or metal-rich emissions. Radio observatories are listening for any coherent patterns of emission, though none have yet been found. Meanwhile, theoretical physicists are building dynamic models that could reconcile the observations with angular momentum and energy conservation. Each test, whether confirming or debunking, brings us closer to an answer and further into the realization that 3I Atlas has changed the way we think about interstellar visitors. As the scientific world waits for new data, a broader reflection is taking shape. 3I Atlas has reminded us that the universe still holds surprises sharp enough to pierce our certainty. Whether this anomaly proves to be an artifact of exotic physics or something more deliberate, it stands as a monument to curiosity, the drive to keep looking, even when what we see defies reason. The object itself will soon vanish into the darkness between stars, but its legacy will linger in equations, arguments, and dreams. Humanity's encounter with 3I Atlas is more than an astronomical event. It is a philosophical reckoning with the limits of knowledge. And as its 12th anomaly continues to defy explanation, one truth remains unescapable. The cosmos is speaking in a language we are only beginning to learn.